Okay, it looks like we're live. Let me just listen to my iPad here and make sure we have audio.
Okay.
Oh yeah. Got a lot of hissing, that's what I got. Hang on. Yep. We're good. So I'm going to close that. And really quickly, before we get going, I'll pull up the chat stream for this, so we don't lose anybody.
Okay.
And really quickly, before we get pop that out. Okay, we're good.
Excellent.
We're live, and I am following you in Visual Studio Code. So
Okay.
I'm Brian Kettleson, and I'm just going to do a quick intro for those watching later. I'm with Kevin Hoffman. We're going to talk about Wasm on the server side and waPC, which is a new spec that he's created, I'm assuming with others, to do RPC calls to and from a Wasm host. Kevin, can you introduce yourself and correct all of the things I said that are wrong there?
Nope, it's pretty accurate. I'm Kevin Hoffman. I've been doing services and service stuff in the cloud for a while. I spent about a year or so at Pivotal, and now working for Capital One.
Awesome.
And I got into WebAssembly. I'm not even sure how long ago it was. It was definitely very early into it, although I guess you could say that it's still early. And then wrote a book on Rust and WebAssembly, and that's essentially what got me into the space of running WebAssembly on servers.
And I love WebAssembly as a concept. How are you finding the idea of server-side WebAssembly? Are you seeing a lot of pushback, or people just wondering why? Or do you think there's some with the the Fastly's Lucet and what's Cloudflare's called? I can't remember. They've got a execution engine. There's a handful of execution engines out there for server side. It seems like people, at least on the edge, really like the idea of server side. What's the pull for you?
So I think there were a couple of questions there. I'll try and answer them in order. So when I talk to people about running WebAssembly in the cloud or running it server side, there's generally two reactions. The first is people who aren't really all that familiar with WebAssembly in general. They just really don't know how WebAssembly can be applied to something like the server. And so then that's generally where I'll do some explanation in terms of what WebAssembly is, how it works, and why it's not just for the browser. Once I get to that point, then we have the second audience, which is people that are vaguely familiar with WebAssembly, and they know, they sort of get the idea that WebAssembly is a portable virtual machine format. And with that as a foundation, the idea of having that portability run on servers and other devices, embedded hardware is pretty popular too, IoT, those types of things. I think people they're starting to see the possibility and there are an awful lot of problems that could be solved. What I think is still in its infancy is the ecosystem for this. It's pretty much why I've spent the last 6 months or so writing open source libraries and tools for it, is because I personally think that WebAssembly is the next Docker, and I want to see it succeed in the cloud and on servers to sort of follow through on that vision.
All right, can we start with some acronym explanation? I know there's Wasm for WebAssembly, and then on the server side there's WASI. Now,
Yep.
are we dealing specifically in WASI here, or is WASI separate from what we're talking about today?
When I do presentations on WebAssembly, I kind of go over the notion that there's kind of a split in terms of what people are doing with WebAssembly on the server, or just non-browser WebAssembly. One branch is WASI, which stands for WebAssembly System Interfaces, and one branch is what I'm doing. And the WASI branch, stop me if some of this stuff is not, if you're not familiar with the internals of WebAssembly, but basically the way WASI works is you compile code in whatever language you're using that can normally generate WebAssembly, and whenever the compiler gets to a spot where it would find a low-level system call, like acquiring a file handle and writing to sockets. When it gets to one of those calls, instead of replacing it with the native call like the compiler normally would, it replaces it with a call to an import that it expects the host to supply, the host runtime. So in a browser, the host runtime is JavaScript, and the host runtime provides capabilities like DOM manipulation. And with WASI, the host runtime is required to supply, I think it's in the 30s or so, but some 30-odd imports that essentially allow a WebAssembly module to make certain types of syscalls. And so the benefits of going down that path are fairly obvious. You get theoretically, you get all the benefits of WebAssembly, but you can also, under the right runtime, you can make system calls. And so that means that your WebAssembly module can write the standard out, can make network calls, can access a subset of the file system, things like that. My view on this, or at least the take that I've been going on from the beginning, is to embrace the WebAssembly sandbox rather than poke holes in it. And so when I get to some of the stuff that I built a little later, I'll demonstrate some of it. But when you have this portable, isolated sandbox with a completely predictable list of things that it can and can't do, when you attach it to something like a WASI host runtime, you no longer have the control over that sandbox. You can, a WebAssembly module can make unfettered syscalls. There's a bunch of security at the low level so that those, syscalls can't be forged and whatnot, but it doesn't have any high level security that, saying this module can access this file and this one can't, and things like that. So, the road that I've been going down is to embrace and strengthen the sandbox that WebAssembly has. So I don't use WASI. All of the capabilities that I'm granting to WebAssembly are all done through host imports, which is how WASI does it. But the security layer on top of those imports is at a higher level. So there's a bunch of control over what capabilities the WebAssembly modules can and can't perform.
Okay. So is that our segue into Waxo suit?
Yeah, it would be. It's not. It's
Not
no
today,
longer called.
Satan.
It's no longer called Waxo suit. It's just WASCA, WebAssembly Secure Capabilities Adapter.
Okay.
But yes, so there's I forget the term, whether it's cake diagram or stack diagram or whatever. But if you picture this ecosystem in layers, at the very bottom you have the runtime that's responsible for interpreting the virtual machine bytecode, and that's WASMer, which sits on top of Lucet, which sits on top of CraneLift, and so on. So it's Rust all the way down at that point. And then above the WASMer runtime is waPC, which is what we're looking at now, and that allows us to exchange arbitrary function calls between WebAssembly and the host runtime. And not a lot of people are aware of it, but WebAssembly has a number of limitations, and one of those is that you can only pass numeric arguments to WebAssembly calls, and you can only get a single numeric response. So even things as simple as hello world are often really difficult and easy to get wrong, because all you can pass are numbers. And so some layer above the pure numeric function calls needs to be put in place so that there's a well-defined set of standards on how to exchange arbitrary payloads. And that's what waPC is. And you were right in that it's not just me doing this. A colleague of mine was instrumental in helping figure out what that procedure call standard is.
Great. So with waPC, you have a standard for the runtime. Let me rephrase that. A standard for a Wasm binary, a Wasm bytecode to talk to the host that's running the process. That's the server.
Yeah. So the standard defines a way for the host to make function calls inside the guest module, and the guest module is the WebAssembly module. And it also defines a standard for how the guest module can make function calls on the host.
You said that so much better than I did. So, for example, if you wanted to write a guest module that acted as a network server, let's say we're going to write our own telnet server in WebAssembly, you would use the waPC layer to expose the function calls that allowed networking, for example? Or am I stack?
So you may actually be a little higher than waPC. If I was going to do a telnet server, that's when I would use Wasco, and I would write the socket server that listens on the telnet port as a capability provider. And I've got some demos and some code that we can go through after we get past the waPC stuff, where I can show what the difference is between writing code for waPC versus writing it for Wasco.
Okay. Well, how about if I shut the hell up and you can demo things, and maybe things will start to fall into place and make good sense for us.
Okay.
By us, I mean me.
Okay. So what we're looking at is essentially the Hello World equivalent of WebAssembly. And so typically your Hello World for WebAssembly module, you'll see samples where it's, add the numbers 1 and 1. And, if you get 2 to show up in your browser or on your command line, then everything works and it's great. But as with most Hello Worlds, we almost never have purely numeric arguments. So the Hello World that I think is of minimal practical value here is being able to send and receive arbitrary binary blobs. And so if you're not familiar with the Rust syntax, what we have inside the WebAssembly module is a macro that essentially identifies our handler. So the way this works is the WebAssembly module is purely reactive. It doesn't initiate anything unless triggered to do so by the host. So unlike a main function in some other language where as soon as you run your code, it starts doing something, the guest module is dormant until the host module tells it to do something. And this could be the host module just invoking a random function, or if you're up in the WASCA level of the stack, it could be, it received an HTTP request or it received a message from a broker. I'm still going back and forth on whether or not I think I need an initialize function to call when the module starts up. But every time I have that argument, I end up on the side of wanting to keep it as reactive as possible, because having an initialize function makes me want to put state in it, and I don't want state in these things. So in my handler, I've just got the name of the operation that the host is attempting to invoke, and then essentially just a slice of bytes. And so I just, in this sample here, I'm looking for an operation name with this string. And just by convention, I'm using a namespace prefix with a colon, and then a module prefix, and then an exclamation point and the operation name.
Okay.
It's purely convention, and it's the convention that WASCA uses. But if you're just doing WAPC code, it doesn't matter. As long as the host and the module agree on what operations should be called, they can be called anything. They're just strings.
Okay.
So in this case, if I get this operation, I'll call this function. Otherwise, I'll complain to the host that it tried to invoke something that I'm not ready to handle. So the hello world function here disregards the input and just returns this string as a byte array, and the little b in front of the string here in Rust just converts that into bytes.
Okay, and the disregarding the message is the underscore?
Yeah, so Rust is going to aggressively check my use of variables. And so if I remove the underscore, now I've got a complaint that I've got an unused variable. So if I prefix it with underscore, it marks it as intentionally unused.
Yeah, I'm fully familiar with that from the Go world. Okay.
Okay. So the first thing we want to do is compile this. And the only prerequisite for this is just having access to this little guest SDK, which is just a crate that's available on crates.io. And so if you're building this in Rust, you just grab a dependency on that, and that's where this macro comes from. And I'll show you in a minute that other languages don't need that SDK. This is all just for convenience.
Okay.
So let's see. This is in Hello One. Cargo build. You can see the terminal, right? Okay. Yeah, I'm a little new to the VS Code sharing, so I'm not sure if I disappear, I do something stupid. Let me know.
I will. It's going great so far.
Okay. So, the analogy for WebAssembly modules is that they're like game console cartridges or disks, and so they just have raw data on them, and they're utterly useless without a host runtime. So the host runtime for a game console is, it's your PlayStation unit, and in this case, the host runtime is a binary called Waxo. But as I said, the name is going to change slightly, but it's just a simple process that is responsible for reading the module. And actually, in waPC, the host is just a process that we wrote. So I'll show you that now. So we've compiled the WebAssembly module, and now we want to run the WebAssembly file. I'll skip past some of the stuff that's Rust specific, but the first thing we do is we just create a new waPC host, and so this host variable is now a waPC host runtime, and it gives me essentially two things. The first is it lets me set a function that gets called when the guest WebAssembly module makes a host call, and it gives me a function called call that lets me invoke these functions. And you saw this string in the WebAssembly module. This is the operation name, and this is just the arbitrary set of bytes to pass as an argument.
Okay.
And the result from this call is a Rust result that, if successful, contains a list of bytes. So I send it some bytes and I get some bytes back. At the waPC level, there's no enforcement on that contract. It's up to the host and guest to agree on a schema for what they're going to put in those bytes. And so in this case, I just happen to know ahead of time that these are UTF-8 encoded strings.
All right, and you're passing the Wasm module file name in on the command line to run.
Yeah, so there's some magic happening in this struct thing that converts this parameter into a command line option. So if I go into runner, you'll see that now it needs the input variable, and that's the same as this. So so if I run this with the Wasm file as input,
wow,
I got hello world from the WebAssembly file, and this WebAssembly file is, let's see, it's debugged, but let's see what the size is. It is 3 megs. So the business logic is contained in its as close to its purest form as you can get in that module. The thing that I think is an underrated bonus of using these WebAssembly modules is that they are internally consistent and have no physical dependencies outside that WebAssembly module. It's just an encoded set of business logic, and anything that module needs to do, the runtime has to allow it to happen. And so, you can think of having all sorts of different custom runtimes. There's one for the browser. There's Lucid's Terrarium has a custom runtime for essentially lambdas that have the only thing they can do is make and receive HTTP calls. But that's a custom runtime. WAPC is a custom runtime. WASCA is a custom runtime built on top of WAPC. So
this is amazing that we're looking at 37-ish lines of code, which is really 20 or fewer lines of code after you get rid of all the imports, that allows you to instantiate a Wasm runtime that can open up a Wasm module and execute an arbitrary method in it. That's about standing on the shoulders. That's a lot of work already done for me.
Yeah, and the standing on the shoulders thing continues up the stack, and so you'll see more of that theme as we go on. But one of the things that I've seen far too much of in my career, building services before they were called services, building microservices before they were called microservices, is every time we get a new set of requirements, the first thing we do is we build a little hello world that proves that that particular type of business logic is possible. And so we've got our little prototype and everybody's happy with it. And then we go and start the road from prototype to prod. And that's where everything goes downhill almost immediately, because this thing needs to be able to do logging, and we need application monitoring, and it needs security, and it needs network connectivity, and it needs to be able to do these other 20 non-functional requirements. And so we just start throwing boilerplate into our code by the shovelful, and we spend 90% of our time essentially herding boilerplate, and only 10% of our time working on the business features. And the goal here is that if we do this right, then we can reverse that ratio, and we can build our business logic in a few lines of code that compile to a portable format that is OS and processor independent and will run in any number of different runtimes. And it's got enterprise security and stuff in it when we go higher up the stack too.
So that's the most concise value proposition I've heard in a really long time.
Thank you.
Reverse that boilerplate. That's fantastic. Remember that when you're going back to the website and fixing the docs, which I noticed is still empty-ish, but
yeah. There's two sets of docs. One is old, one is new, and mostly empty. This essentially is because we've been changing things so fast that I didn't want to confuse people by putting out information I knew was going to be out of date within a few hours. And so we've been building up to a demo that we're going to do at KubeCon of an online multiplayer game engine server that we built out of WASCA. And once we do that demo, then I'll be able to go back in and start codifying some of the things that we did in the form of documentation and tutorials and samples. And we'll also be able to work on the Go SDK and more of the stuff that I've been unfortunately having to put off.
Sure.
But one of the other things that's I think also compelling here is that the exchange between the host and the guest is two-way, and so it's not just the host being able to invoke functions and get an answer from the guest. The guest can also make host calls in response to that stimulus. So right here on our hello world, we're just returning an answer, but we could also very easily make a host call and do something with that. So here, I'm following the same call pattern where it's just an operation name and an arbitrary set of bytes. So this is going to send it to the host. And in our host runner, you saw that we've set a host callback. And so in this case, it's just going to dump out what the callback was. But this pattern is used for things, is the one that grants the WebAssembly module's capabilities. So when we get into WASCA, these types of host calls are used for making queries against a key value store, for publishing messages on a message broker, for making HTTP client requests, and so on. So let's I'll show how this two-way action works. Go recompile hello one here. So now you can see I called a function on the guest module. The guest module then called a function on the host runtime, got an answer, and then when it was done, it returned a result. So these are more than just lambdas, because in the purest functional form of a lambda, right? You send it some event, it does processing, and the response is an answer. And for AWS, it's essentially JSON payloads that you're playing with. But here, what we have is the ability for your WebAssembly module to do both, and it's still just one line of code added. This call could be an enormously complicated capability provided by the host, but it's still, at least from the WebAssembly module's point of view, just a declaration of intent. All it's saying is, please host do this for me. And so as a result, the developer doesn't have to write much more code to get it done. These functions are extremely easy to write unit tests for, and with the right host runtime in place, you can imagine some pretty robust scenarios where you can do automated acceptance testing as well, because you can simulate any of the host runtime capabilities.
Yeah, or substitute them for different environments. There's that. Yeah, that's setting off all kinds of interesting ideas in my head.
Yeah. When I get to the WASCA stuff, I'll show how the capability providers are plugins that are swappable. So without recompiling your WebAssembly module, you could get your key value stuff from Redis, and then without even taking the system down, you could switch it to a Cassandra store and never have to recompile the WebAssembly module.
Wow.
So let's see. Any questions before I go from WAPC to WASCA?
I don't think so. You mentioned that WAPC is generally language agnostic. Did you have a demo of calling into or out of WAPC from another language?
Yes. Thank you for reminding me. I would have just gone completely past that. So yeah, WAPC is language agnostic, and well, so is all of WebAssembly in theory. Although the current version of Go does not abide by all of the WebAssembly standards, which is why I don't have a Go SDK.
Okay.
For this stuff. TinyGo does, but RealGo made assumptions about the runtime host being JavaScript, and as such doesn't work for console hosts. kind of unfortunate.
Yeah, and TinyGo's got a lot of limitations in terms of the standard library things that it supports, like reflection is really spotty.
Yeah, so that's where I ran into some issues too, where I was able to get TinyGo to play nice with the contract in order to satisfy the WAPC back and forth. But once I tried to get into the Wasco level, which uses protobufs, TinyGo stopped being an option there because at least the version that I tried wasn't able to support the protobuf library.
Right.
Okay, so yeah, another thing that we've got is, like I said, if the guest module and the host runtime are all playing by the same WAPC rules, it doesn't make any difference what language either of them were written in. So I can use the Rust runner to compile or to run a Wasm file that was written in any language, including Zig. I don't know if you're all that familiar with Zig.
I am. Zig is one of my new favorite toys. When was it WAPM? Is it WASI or WAPM? When the WebAssembly Package Manager came out,
yep.
I think 30 minutes after they released it, I released a Hello World package on WAPM from Zig, and I was really excited about how easy that was.
Yeah, that's pretty cool. I've just don't have enough time to play as much with Zig as I want to. But one of my favorite features about Zig is the use of explicit memory allocators. I know people who hate it, but those people are also more comfortable in higher level languages. But so in this case with Zig, instead of the Rust version of importing the SDK, we're just creating the SDK here as a constant. And this is actually the FFI name for the function that we need to export. And there are some other ones to do back and forth, but this is the low-level function name. And here we're just declaring that we're going to respond to a function with this operation name. And in response to that, it's just manually creating some memory space and then filling it with a hello string, and then finally attaching an exclamation point to it. So if I go into the Zig directory here, I'll show you the build command just so you can see, but this is just going to use Zig to build a target called Wasm32 freestanding. Zig's compiler is obviously pretty fast, but we're also not building much. The Wasm file here,
tiny.
Yeah, it's pretty small. So if we've done it properly, then the runner should be able to run the Zig file and have everything execute without any regard for the fact that there was a different language being used. There we go. So we have A from Zig. This was the Zig WebAssembly function, or making a call on the host and then returning an answer to the host. The host obviously did not need to be recompiled in order to host two completely different WebAssembly modules.
And there's nothing stopping you in your runner code from loading more than one WebAssembly module and using some sort of switch or conditional to decide which one of those you're going to execute too.
Nope,
Your runner is simple; it's just executing a thing, but you could very easily make that a daemon that loaded a whole folder of them, and
It could, yep. So you could just create a large number of these WAPC hosts, and then, like you said, create some form of dispatch mechanism that chooses which function, which module gets which function. And it's another reason why I generally default to using this like namespace and module prefix, because if each module were to register something like a namespace and a module, the module could be the file name, then you'd already have a built-in key to use for dispatching.
Very nice. This is so impressive. I'm blown away by how nicely this works across languages, and wow. Now, talk to me about speed. Have you done any sort of benchmarking? Do you have any idea what the cost is of doing this in WebAssembly, hosting it in your runtime versus bare metal?
Yeah, so this is where building on the shoulders of other giants comes in extremely handy, because when I first started out on this project, I was essentially shopping around for either languages and runtimes that I could use for a host. So I played with Elixir, thinking I might be able to gain some advantage with OTP. I looked at some other languages, and the Rust runtimes were the fastest. And then when I finally found, when I originally was using a runtime that I believe is being used by a cryptocurrency, I switched from that to Wasm, and the performance was insane. The way Wasm works is it takes all of the instructions that are in your WebAssembly code and jits them into native instructions. So your first call into your WebAssembly module is, think of that as your cold start on a Lambda. And thereafter, you get native performance. And when I say native, it is indistinguishable from the same speed you would get from a C-compiled OS processor native binary.
Wow. So why isn't everybody in the world doing this yet? Is it because we haven't evangelized it enough?
I believe that's most of it. We haven't evangelized it enough. I'm, in theory, working on that. I've been trying to scream from the rooftops how big this is. Like I said, I think WebAssembly is the new Docker. But the other is ecosystem, right? We don't have a giant pile of tooling and shiny, attractive things to show people. The things that WebAssembly tends to do, or at least that we tend to see with the WebAssembly community, is we see the shiny, flashy browser demos where people are doing things like porting Doom to run in the browser and other things like that. And it's impressive, and it draws attention, but it's not doing server-side WebAssembly any favors. By and large, when I speak at conferences or meetups, the majority of the audience is pretty much just familiar with the idea that WebAssembly is, vaguely some kind of JavaScript replacement.
It's a magical thing that you can throw on your website that makes calculating pi a little faster.
Yeah, and it also doesn't help that, I don't know if you saw that recently there was a study put out that showed that when they scraped a bunch of websites running WebAssembly, they found half of them were loaded with malware.
Oh, nice.
So, security is a thing too. It's got to be something we put into these types of things from the ground up, and not bolted on as an afterthought.
So let's go back and Earlier, you mentioned the idea of all of the boilerplate being built into these services that you're writing. It feels like, the next level up is where that boilerplate goes, and I'm assuming that's where Waxo Suite is. Do you have some sort of concept of what would the supporting libraries that you would add to Waxo Suite, things like logging and observability? Is there am I jumping the gun here? But is there a suite of pluggable services that you're thinking of in terms of the host?
Yes, that is exactly what Waxo Suite is, or WASCA. So, if we think of waPC as like an untyped or a loosely typed contract between the guest and the host, then WASCA on top of that is the strongly typed version, and it's designed specifically to allow named capabilities to be accessed by the guest module, and to still allow the host module to invoke functions on the guest. And more importantly, the binding of these capabilities to the guest module is always done in a secure fashion with cryptographically secure signed JSON tokens. And I'll go through what that is and why it's there. But in short, what it means is that once we put that new strongly typed layer on top of waPC, we can add another set of benefits and build on yet another set of shoulders. And one of those benefits is being able to make the claim that if we don't authorize a particular Wasm file to make HTTP client calls, it will not be able to make those client calls because the HTTP client capability literally will not be in memory.
Amazing.
So there's a little bit more tooling around WASCA than there is around waPC, but it's still... So Cargo, the build tool for Rust, has a function where I can generate a new project based on a template. And let's see if I can remember this from... So this should, in theory, generate an empty WASCA WebAssembly module based on this template. So I now have this new WebAssembly module, and it should... Nothing's cached, so pardon the compile time. And again, you see all these dependencies fly by in this compilation, but the end result in the Wasm file only includes the functions that you actually invoked. Mm-hmm. So this is going to compile, but it's still going to produce a super tiny binary. Okay. So what we have inside the empty Waxo Suite module is something very similar. So instead of a waPC handler, we now have a call handler macro. And if you were to look into the internals of that, you'd see that this handler macro actually calls the waPC handler macro. So we're literally building directly on top of waPC.
Okay.
And the difference between the waPC call and the WASCA call is this thing called the capabilities context. And this is a struct with operations on it that allow you to access well-known publicized capability abstractions. So you use the capabilities context to access a key value store, to log to standard out, to access a message broker, to access the HTTP client, and so on. And then we still have the the other two parameters, the operation name and the message. And in keeping with the strongly typed pattern, we have constants now to represent the well-known operations. So you can still support completely arbitrary operation names, but if it's one of the ones that WASCA knows how to deal with, then you can just use the constant for it. And so in this case, we have health requests. So one of the things that you get for free when you push your WebAssembly module inside the WASCA runtime is the WASCA runtime automatically exposes health checks that are container scheduler friendly. So out of the box, this stuff will pass Kubernetes health and readiness checks. Mm-hmm. And all you have to do is return OK to indicate that your module is healthy. You can obviously add more logic to it, but the theme here is this is a declaration of intent, not a list of imperative steps in order to satisfy that intent. So this is pure business logic that says, am I healthy? It's completely unconcerned with how it physically represents its health status to the outside world. Mm-hmm. And so in this case, we also have the ability to handle an HTTP request. And you'll see here that it's not manipulating a network stream. It's not creating side effects. It's not doing the types of things where we normally get the giant tentacular mess from our boilerplate. It's taking the capabilities context and the payload that it got from the request and returning a response. And so in this case, we're converting this JSON payload into a JSON response and then encoding it as protobuf bytes. And I've got some code in a branch that removes the need to call this protobytes thing. There's a way that I can make it implicitly convert stuff into protobuf bytes, but that's just syntactic sugar. So I've now compiled this, and what's missing now is the secure binding between this module and the capabilities. And we know that we need this module to have the ability to serve HTTP, right? Mm-hmm. So if I build a release version of this module, at the very end, you'll see, as it pauses longer than I was hoping for, and it's still building. The only thing I will complain about Rust is the build times. And it's only because I can't seem to figure out when things are going to be cached and when they're not. So it continually surprises me with builds that take less time than I expected and builds that take more time.
I'm using, I think it's called Starship as my bash prompt. And every time I build it, I think, oh, thank God I don't use Rust.
So at the end of building the release binary, I used a binary called WASCAP. This is just a command line tool that is used to sign WebAssembly modules. So I'm signing this WebAssembly module. This is the output name, and this is the account key, and this is the module key used for the signature. And I can get into detail on that later if you want. But This right here says that I want to sign it with the HTTP server capability. Now,
what are you pointing at? Because I don't see. I don't see
sorry.
Or anything.
Okay. See, that's the thing. I didn't know you didn't see that. Can you see my highlights?
No, all I see right now is that you are in the librs. If you're on highlighting in the terminal, we can't see that.
Okay, yeah, I'm down in the terminal.
Okay.
Okay, so, but you can see the terminal output, right?
Yeah, we see the terminal, just can't see your cursor in the terminal.
Okay, that's good to know. So at the very end, there's a -S, and that just says, that just indicates that I'm going to grant this thing the HTTP server capability, and the authorization for that grant comes from this account. So if I don't trust the account, then I won't give it the ability to make this HTTP server call.
Oh, interesting. Okay.
So I can then examine the capabilities of any given WebAssembly module by just using this caps. Let me just expand that. So you see I've got the account. This is the account's public key. Sorry, you can't see my double clicking, but there's an account public key and a module public key. There's an expiration date, when this can be used. So these two are the expiration date and the when it can be used. Those are standard fields that come with any JSON Web Token. The capabilities are things that I've added. So this actually shows that that this module has the HTTP server capability. But I can also add arbitrary tags to these modules. So, you can imagine a complex build pipeline or something like that using tags to, drop metadata on these things. Mm-hmm. So if I didn't have that HTTP server capability, I wouldn't be able to run it. So, as I mentioned before, crane lift is used underneath. Mm-hmm. And by default, its log output is super spammy. So I always have to do. So I'm going to run this module, and I apologize for not having Waxasuit in my path. I have 5 different copies of it on my machine in various states of development, so I need to be able to explicitly control which one I use. I've literally spent 4 hours troubleshooting a problem because I was using the wrong build of Waxasuit.
Relatable.
So the input is and I need to tell it where to find the capability provider plugins. As I said, those are all dynamically loaded. So the Redis provider, the NATS provider, those are all dynamically loaded. So this should, typo here. Okay. So can you see you can see the log output?
Yes.
Okay. So there's some line entries here where you can see that it's loaded the HTTP client capability. But then the line after that says that the capability provider for it wasn't claimed by the guest module. So it literally unloaded that plugin. It will do the same thing for messaging. It does not have access to NATS, so the messaging provider plugin was physically removed from memory. And the same thing with key value. It doesn't have access to the key value store, so that was removed from memory. The only thing that remained was the web server. And so that it now has a web server running on port 8080. What's the best way to get another terminal here?
Just hit the plus button. Plus button where the terminals are. There you go.
Okay. So first thing I want to show is some of the stuff that you get for free. So there's the automatic health endpoint for Kubernetes to make Kubernetes happy.
Very nice.
There's an ID endpoint. So I can, at any time, I can curl the ID endpoint of a running waXA host runtime and get the public keys of the module that it's currently hosting, as well as the capabilities that it's been granted access to. And then, I can then just curl it. And this is just returning, so that the code just returned an HTTP OK. So there's no data there, but you can see I'm logging all the good stuff here. So you can see the second to last line, you can see.
Hang on.
So on the second to last line, you can see that it's performing a guest call, and it's the HTTP server handle request. So there's a bunch of stuff going on here, but one of the really important non-functional requirements that we can get for free here is full tracing. So the Wasco runtime knows every time a guest makes a call, and it knows every time the host makes a call. So it can automatically add correlation IDs to that so that it can be compatible with distributed tracing systems like Jaeger. And so, again, we get that all for free. We'll also be able to get things like APM stats, so we can optionally push to a Prometheus collection agent. Mm-hmm. And those are, again, things the developer doesn't have to worry about.
Yeah, that's really nice.
So, that's what you get with the standard Hello World, or the empty template. Let's see.
Can you dive in just a little bit on the capability providers? So I know we're using a capability provider, but what does one look like? So we're using this capability provider that provides HTTP server.
Yep.
I'm assuming that's a thing that you also had to write.
Yep. So what part of the capability provider did you want to? So there's essentially the consumption side, so how your WebAssembly module consumes a capability provider, and then there's how you write a capability provider plugin.
I'm curious about the writing one. So we want to provide a brand new capability. You said you cover key value stores and HTTP and NATs. Let's say we want to provide something like MySQL or some database thing. What does that look like? What's the process look like?
All right, so I have a tutorial that'll be published right after KubeCon that shows it, but I'll take you through, say, the NATs. Hello?
I'm here.
Okay. Can you hear me?
I can, yes.
Okay. That was unexpected. I didn't realize that opening a new folder would completely ruin the live share.
It's okay. We got back in quick.
That's almost frightening. So building a capability provider can be done in any language. The only difference now is that you have to conform to a CFFI standard instead of a WebAssembly standard. So these are dynamically loaded Linux libraries.
Okay.
So to build one of these in Rust, there's a trait called capability provider that you implement, and as long as you implement that provider and use this macro to indicate the name of your provider and the constructor to call, and then your provider is capable of exposing any service. And so the capability ID for the NATS one is messaging. And so again, the capability ID is an abstraction, and the provider is a binding to that abstraction. So in theory, I should be able to, I could unload, I could use NATS for my messaging provider, or I could use RabbitMQ, or I could use Kafka for my messaging provider. And assuming that I still adhere to some base set of common functionality, I should not have to, those should all work, and I shouldn't have to recompile my WebAssembly module.
Okay.
So to build a capability provider, the first thing I need to do is allow the host to know what my capability ID is. And so in this case, it's messaging. And then I have to configure the dispatcher. So WASCA, the WASCA runtime creates a dispatcher per capability provider plugin, and that allows the capability providers to send messages to the guest module. And it's a bit more of a complicated problem than I originally thought it would be, because WebAssembly is single-threaded. Mm-hmm. It does not allow reentrant execution, and you can't start a thread from inside a WebAssembly module. So that bidirectional execution where the host calls the guest and then the guest can call the host, if any of those things result in further interaction with other providers, that stuff's all got to be multiplexed somehow. So inside the WASCA runtime is a multiplexer and a dispatcher system. And so the dispatcher is what allows the plugin to talk to the guest module. So if we look at on line, you can see my cursor now, right? Mm-hmm. From inside here. Okay. So on this line, you can see when I receive a message on NATS as a result of a subscription, I dispatch the deliver message to the guest module. And this plugin doesn't care how that dispatch is delivered, only that it will be, and whether or not it resulted in an error. And so, we have these asynchronous subscriptions that are constantly receiving messages that are still able to deliver single-threaded messaging into the guest module and still allow the guest module to make outbound NATS publication calls without interfering with anything. And there's a recurring theme of embracing some of these limitations. So, embracing the WebAssembly sandbox. But the other thing that you get some benefits from by embracing the single-threaded model is I can, with the WASCA runtime, you can literally pause it, swap an entire WebAssembly module out and with a replacement module, and then resume it without ever dropping any messages, because of the way the dispatcher and multiplexer work. So one of the things that the WASCA runtime can do is a true zero downtime upgrade if you do a quote unquote zero downtime upgrade in Kubernetes, what you really get is you have to provision a new copy of the thing that nobody can see, and then move traffic over to the new thing, and then dispose of the old thing.
Right.
And so what happens sometimes is you don't have enough resources to provision the new thing, and so your so-called zero downtime upgrade actually fails in place.
Yeah, if I had $1 for every time I didn't have enough memory to allocate another pod so I could upgrade a thing.
Yeah, so what you can do here is you can take a currently running WASCA runtime process and literally send it a new WebAssembly module over the control plane, and it will replace the WebAssembly module without ever dropping a message, even if it's actively receiving, 10,000 messages a second.
Wow. That's amazing.
When you build your capability provider, you essentially just have a couple of responsibilities. The first one is to tell the host what the capability ID is. The second one is to accept a dispatcher from the host, which is your abstraction through which you communicate with the guest module. Mm-hmm. You need to provide a friendly name. So this is the NATS messaging provider. This allows you to distinguish between multiple messaging providers. So, like I said, the capability ID is the abstraction of the capability, and then the name is the specific implementation. And then the real work comes here, which is handle call. That function gets called when the guest module makes a request of your capability. So, like I said, there's a dispatcher and a multiplexer, and the multiplexer takes the outbound requests from the WebAssembly module and figures out which capability provider is the one that's supposed to handle that operation. And so in this case, if there is a function call request bound for the messaging capability, it'll be delivered to this plugin, and the handle call method will be invoked here. And you can see the messaging provider supports two different operations: publish message and perform request. But the KV store, I think, has like 30 operations, and the HTTP client one has one. But the thing about these capabilities is, like I said, they're abstractions, and they're dynamically loaded plugins. So if you know ahead of time you're never going to need a particular capability, you don't even need to put it in your Docker image that you publish. And so you can essentially preload only the ones that you know are possible. And even then, if the module doesn't have permission to run it, it'll be physically unloaded from memory. So there's no way you can compromise a WebAssembly module to allow it to access a capability that it's not allowed to access, because it physically won't be in memory. But these capabilities are also able to do things more than just traditional cloud stuff. So you could use the same WASCA runtime to access a capability that's exposed by a Raspberry Pi host to give it access to hardware. And this is where some of the portability of WebAssembly modules just becomes absolutely mind-blowing, because you could, in theory, have a web-based acceptance test harness to test your WebAssembly hardware module with simulators in it, and then you could just drop it directly into a Raspberry Pi or some other embedded device and essentially treat a secure WASCA WebAssembly module like it was firmware.
That's just crazy.
Yeah, I've actually got it. I have it running on one of my Raspberry Pis. one of the samples in the book kind of gave me the idea for it. Is I have a WebAssembly. I have a host runtime that accesses a thing called a blinked, which is an 8 LED stick, and I can hot swap live over HTTP the brains that controls the blinking pattern with the WebAssembly module. So I shoot one WebAssembly module out, and it's displaying, the Battlestar Galactica Cylon pattern, and then I shoot another WebAssembly out, and it just flashes. And so, I've got hot swappable firmware in the same host runtime that I can use to deploy stuff in Kubernetes.
That's mind-blowing.
Yeah, it's pretty crazy.
So we're just a few minutes from the end of our stream. Where do you want to send people to get more information about this? I know there's the website. Is that changing? Is the address changing? I have Waxo suit.
Yeah, so let's see.
Is that going to be WASCA soon?
Let me just make sure that still resolves. I had an issue with the DNS yesterday. Yep. Okay, so it's wasca.io. And the documentation there is, again, still in flux. Expect it to become far more well-rounded after I get some spare time back after KubeCon. And then you can always go to the GitHub org, which is WASCA runtime. And there you'll see a ton of stuff, including the core runtime. The WAPC layer is a different GitHub org. And so, one of the reasons why WAPC is separated from WASCA is that, it allows the low-level stuff to get better and faster and more robust on a completely separate release cadence as WASCA is. So, as long as WASCA is depending on WAPC, you can opt into this ecosystem at any level. You can choose to start building your own stuff on top of just the loosely typed contract, or if the idea of securely binding capabilities to WebAssembly modules is where you want to go, then you're going to want to opt in at the WASCA level. And I don't want to divulge too much, but I have another set of shoulders that I'm building that will build on top of WASCA. There's going to be some pretty amazing stuff in there too, I think.
Well, don't give away the big reveal.
No. And so the other thing, and I don't know if maybe you want to do a follow-up session on it, is I had some demos that I wanted to walk through that showed how to build collaborating microservices with WASCA. So, like I said earlier, the hello worlds are very deceiving because it's very, very easy to build hello world, but once you try and build something of practical value, things start to get complicated very quickly. And part of the reason why I built all this stuff is to reduce developer friction and make it so that we could go from zero to a deployed, fully functioning microservice with all the goodies on top, with no unnecessary friction. Mm-hmm. And so a fairly high level of friction exercise is to build a microservice that exposes a RESTful facade on top of another service that it's calling to get, its own additional information. So the demo I had is an item service that calls a stock service to get its shipping status, and then displays you an aggregate JSON payload. And so one service calling another service over messaging while the other one exposes an HTTP server. That stuff is normally the stuff of nightmares because it's deceptive. We think it's simple, but it's not. But when we use stuff like Wasco, we can. It literally takes 5 minutes per service, and so if you want me to, more than happy to go through that again and talk about that. I've also got the online multiplayer game engine that we built on top of Wasco that I could show as well.
Yeah, let's do a follow-up and dive into some code. This is amazing. I can't even begin to tell you how fast the wheels in my head are spinning with all of the possibilities of all this. This is really impressive, and let's catch up offline and schedule our next stream. I really appreciate your time. I have to ask, is your employer sponsoring this? Are you building this for work, or is this a private time thing?
So this is for work. Essentially what we have is an experiment, and the experiment is, see if we can prove the hypothesis that we can reduce boilerplate, increase security, decrease time to production, decrease time to market, and make things easier to test and easier to maintain, all by embracing WebAssembly on the server. And so that experiment is Wasco. And instead of building some Hello Worlds, we're building some seriously heavy-duty dog food type things in order to validate that hypothesis. And so one of them is a bunch of microservices that is the online game engine, and we actually built a game out of the online game engine to prove that, and that game is what we're going to be demoing at KubeCon.
Awesome. And your employer is Capital One?
Yes.
Are they hiring?
Yes.
Well,
Capital One is always hiring.
Any company that's putting this kind of investment in exciting things might be an interesting place for people to work. Awesome.
Yeah,
well, thank you so much
is.
for your time today, Kevin. This has been
no problem.
mind-blowing. I probably won't be able to do any work the rest of the afternoon. I'm going to have to go sit in a corner and digest all of this.
Yeah, we'll percolate on it, and we can figure out what areas you want to go deeper diving on. And, I'm a huge fan of rabbit holes and tangents, so more than happy to go deep on anything.
Yes. Awesome. All right, well, have a good afternoon, and thanks again.
All right, no problem. You have a good day.
You too.